Right, that new hub for the edger shaft is coming along pretty nicely. I've got it flange here, the right depth. I've got a little bit of a register for that blade to sit on. I've got the diameter correct for the bearing here, and the bearing fits on there real good. I've got a couple more things that I've got to do on it. One is I've got to figure out the holes that go in there for mounting that blade on there. If I was a real machinist, that would probably be no problem. I could take it out, stick it on a milling machine, calculate out a bolt circle and punch the holes in there and all that stuff, but nobody ever accused me of being a real machinist. A bale bucker and a Jippo logger, a railroad gandy dancer, conductor brakeman, and a bush pilot, along with about 40 or 50 or 100 other things that I've done in my life, but I've never been a machinist, never claimed to be, and don't play one on TV. So I'm going to have to figure out some other way of doing that. But right now, while I've still got this set up the way it is, I'm going to run just a little bit of a taper on that, a little bit of a chamfer on that end there to make it a little easier to lead that bearing on there, because it's kind of rough along here. I didn't do a real smooth job of welding that up in there. It really wasn't that important. Nobody's going to be grading that when it's all put together. So anyhow, I'm going to just run just a little bit of a lead on that, just a taper on that so that bearing fits over there a little bit easier, just fits on a little bit easier. And I could figure out everything and set that up to 22.5 degrees for a 45 degree taper, or 30 degrees for a 60 degree taper, or 15 degrees for a 30 degree taper, or some other thing like that. But I've got the compound set up now, and it's set on 18 degrees, I guess, so it doesn't, like I said, it doesn't really matter. That's good enough for who it's for, what it's for. So that's what we'll do, and it's not going to take much. All I'm going to do is just enough so that it makes it, just breaks that edge, makes it a little easier to get that bearing on there. Okay, that's all I wanted. That's good enough. Now I got to figure out how I'm going to put those holes in there. I've got to put the holes in there. They've got to be set correctly to mount that blade on there. I've gone all through all of this to get this hub concentric with the shaft. I want to make sure that blade, well, the blade is going to register on this shoulder here that I put on, and that centers that pretty good. Well, anyway, I got to get those holes punched in there and then get them tapped the right size. So anyway, that's the next step, is figuring out how to do that. I've got an idea what I'm going to do. I started setting up a spindle for milling and drilling external on the lathe here some time back, and it was based on a guy by the name of Steve Jordan's videos that he has on YouTube. He's a Brit machinist there, retired, and he does a whole bunch of stuff on how to do things relatively cheap for guys that don't know what they're doing. And he has set up where he set up milling and drilling operations for his Myford lathe and for a cheap Chinese lathe, as he calls it. Well, anyway, I kind of based it on that, so I'm going to break off from working on this right now and try to get that set up so that, and some stuff set up so that I can put those holes in there accurately for that blade to fit on there right. This is my solution to being able to mill and drill on the lathe without using the lathe spindle, or off center from the lathe spindle. Now, it's easy to drill a hole in the lathe if you're running on a center line. You can either put a drill bit in the chuck in the headstock and drill into a fixed piece that's attached to the tailstock or attached to the compound somehow or something like that, or you can mount a piece in the headstock and turn it and put a drill bit in the tailstock, or there are also adapters that you can put a fixed drill bit in a tool post holder or something like that. But that doesn't work if you're going to drill offset holes like here in this blade. So I started building this a couple years ago. This is a ER20 chuck on a shaft here. It's a 3/4 inch shaft. Now, there are other guys that have done similar things. Winky's workshop, he did something similar, and Everett's machine shop, or I think what is it, Everett's Machine Shop. Anyway, there's been several other guys who've done something different. Kind of got this idea, like I said, from those guys. But what I've got here, this is a boring bar holder, and I've got one of these. Came with the lathe when I bought it, with the kit, lathe tool post kit and stuff. Anyway, it's set up for a boring bar. It's got a 1-inch hole in it for a 1-inch boring bar, and then it's got a sleeve that goes in there for a 3/4 inch boring bar. Well, I happen to have 1-inch to 3/4 inch oil light bushings, and I got the idea of taking that 3/4 inch sleeve out of this boring bar holder and putting those bushings in there, and then I can use this ER20 collet holder with the 3/4 inch shaft and run that in there. It maybe not as high speed as what regular roller bearings would be or something, but it's good enough for me. And then the other thing is that this bronze bushing on the end of it is big enough that it can act as a thrust bushing, thrust washer, thrust bearing on that on either end. So I can either make a collar on this end to go so this fits up tight, and then I can use the carriage to move this back and forth, like for milling or something like that. Or I can attach a power supply of some kind on here to spin this, and then I can use it like this to push it in and out. And that's what I'm going to do for right now. I've got a 1/2-inch drive battery operated Milwaukee drill, so I want to use that. I can hook that on here, and then I can set this on the tool post of the lathe and set it up to the right distance and drill these holes out. But I'm going to need to make an adapter to mount that drill onto here. I'll need something, because it'll only open up, of course, to 1/2 inch. This is 3/4 inch. There is a hole through the middle, so I could make it a plug that expanded in there, or I can make a collar to go over the top of it, and then machine it down on this end to 1/2 inch so they can hook the drill up to it. So that's my project for the day here, to do that. I've got to do something to drill these holes in here in that flange for the edger blade, and so that's my solution for doing that, or part of my solution for doing that. Well, like I said, I started this a couple years ago, and then I set it on the shelf because I had too many other things that took priority over fooling around with lathe projects, other than just making parts on the lathe that I needed. I didn't want to take time to fool around making up a whole bunch of tooling and stuff like that, tools for the lathe. I've come up with kind of a plan here on how to drill those holes out. One of the things I'm going to do is make drill bushings to go in those holes. I did that with one of the other pieces that I had that I got a screw broke off down in. Well, that's what I think I'm going to do here. These holes in this edger blade are 1/4 inch, but they're countersunk on the front side of them, so I'm going to go through and put that thing on backwards and put these bushings in from the back side. I've got a piece of 7/8 inch rod. I don't know what it is, just steel of some kind. Like everything I got is just something I picked up somewhere. Anyway, what I'm going to do is cut this back a little bit down to 1/4 inch. Now it only has to be less than 1/8 of an inch, because that blade is only 1/8 of an inch thick, so it doesn't need to stick all the way through. And then I want a head on it that's bigger, and then I think I'm going to stick that in a hole and super glue it in there, and I'll make several of those. I've got 8 holes to do. It's actually too big. So we'll start over again. Too big. Yep, that one's a little too big, so take it down a little bit more. There we go. That's just right, just like that. Now I'll spot drill that, or center drill that, and then put a hole through it. You got to have a big enough drill bit that is fairly stiff so it goes in there pretty straight. I was going to put a number 30 drill bit, a short one, that's real stiff, in there, but drill chuck won't hold a number 30, so we'll put a number 12 drill bit in there. That's close to a 3/16, next to a 3/16, which is a pretty good sized hole to start with. Oh well, let's see, let's check. It's not raining today like it was the last few days, so I should be outside working on some of the projects out there, but I've started making progress on this edger blade shaft and edger blade, and I kind of want to maintain the continuity of it while I'm at it. Now, an experienced anal retentive machinist probably would have done this a whole lot different. Somebody like Joe Paisniski or one of those other guys that is an experienced machinist, a real machinist, and not a make-believe one like me. I don't even pretend to be a make-believe one, but anyway, they'd have probably done this a lot different. They could have measured out the hole spacing on this and the hole diameter on these holes and laid it all out and all that kind of stuff on a milling machine and figured out all kinds of fancy ways to do it, but I'm not that experienced. I don't have that experience, and I got to try to do things a simple way. So this is what I come up with. I've got these little buttons in here made up to be drill guides, and of course somebody that was real precision that had these all turned all to the equal size and everything here on all of these little nipples that stick in there, they'd have been pretty disappointed because all these holes are all different sizes. So these were all turned down to match each one of these holes individually. And then the thickness on these, I just kind of roughed them out, eyeballed them out. A couple of them I had to turn down so they didn't protrude through the blade itself. And then the thickness of the button portion of them, that's just arbitrary. I just set the cut-off tool on there and cut them off and eyeballed them in, so there's none of these that are exactly the same. Well, that would probably drive some of those guys nuts, but it is what it is. It's good enough for what it's doing and good enough for who it's for, as you say. So now what I'm going to do, I'm going to take these out one at a time, clean them up with MEK, and clean up this blade itself, where it's a little bit rusty and stuff on there. I'm going to take some MEK, some Scotch-Brite, clean that up, and some MEK, and then I'm going to glue these down with some super glue to hold them in there, because some of them will hold in on their own. Some of them are in there pretty tight. They're a hard press fit. I've pressed them in finger tight, but they're pressed in. Some of them are in there. They're not loose, they're not sloppy, but they just fit in there good. But they would probably fall out once I set that up on the lathe for what I'm going to do. So anyway, that's what I'm going to do. I'm going to clean these up and glue each one of these in to the holes that they go in, and then I'm going to clean the other side of that up, and I'm going to super glue that to that flange that I made. I put all those buttons on with the crazy glue, and then while that was setting up, I come over here and cleaned the junk off the lathe. I had about 10 pounds of steel chips and oil all over everything. It was getting to be a pretty good mess. Anyway, I got that cleaned up. I put the 4-jaw chuck back in the lathe. I'd left this edger shaft in the 4-jaw chuck, so it didn't get changed. Its position didn't get changed any, so I mounted it up in the lathe. I polished up the back side, or actually the front side or the bottom side of that edger blade, cleaned it up, washed it with MEK. I washed that flange with MEK, and then I put some more of that crazy glue, super glue, around that edger blade and put it up on the shaft. So it lines up on that little stub out, that little stick out register that I made for it. It's centered on there pretty good. And then I just took this chuck and I got the jaws all the way in. I put that in the tailstock, and then I run it up tight against that edger blade to hold it on there while the glue cures. So that's going to be fine. If I was going to do anything with something like this, turn it or anything like that, I would make some kind of a deal to hold it on there, a piece of wood or something like that, to put pressure on there and put a center on it, a live center on it, so he could turn it. But I'm not going to be turning this under power. This is all going to be turned by hand. I've got the tool block all set up square with the lathe center line here, so now I can put my new tool that I made there, that spindle with the ER20 collet chuck in it, and I can put that on there and a drill bit in it and stuff and drill those holes out. So anyway, I'll let this set up for a little while, let that glue set up, and then I can pull that tailstock away from there, that drill chuck away from there, and that should hold on there, and that should do plenty for what I need. Like I said, I'm not going to turn the lathe on, anything like that. That would be a stupid thing to do with those teeth on there. I should take those teeth off of there anyway. They need to be sharpened and cleaned up, so I'll probably do that later. Right now, that's where we're at. I'm letting the glue set up on that, and so the weather's cleared up, so I'll go out and work outside for a little while. Well, this is my setup now. I've got the blade super glued onto the shaft, and then I put that spindle is on the quick change tool holder, and I've got my Milwaukee 1/2-inch drill motor hooked up to it, and then I adjust a cross slide in until I got the hole lined up in the bushing with the drill. And I drilled the first hole out and it went fine, so this is what we're going to do. Okay, alright, here we go again. Wouldn't hurt to use a little bit of cutting oil on there. Okay. Hole number 2. Well, that's working as good as I'd hoped it would. I'm getting all those holes lined up in there perfectly. So this is a pilot drill. It's a number 12 drill bit, and that's what I drill these holes out in these buttons with. So once I get those all drilled out, I can leave everything here in exactly the same position it's at. I'll take that blade off of there and put a number 7 drill bit in there for a pilot hole for a 1/4 inch 20 thread screw. Well, I got 8 holes lined up in there. They all look good. I had one button that fell off, but I got the hole lined up first. It came off probably because of the pressure of the chips swelling up in the hole as it was coming off. So I'm tickled pink over that. Let's see if that blade will pop off of there. Oh yeah, it just popped right off. Thought I was going to have to get the heat gun on it, but popped right off of there. Now just leave everything set up the way it is and change that bit out to finish those holes out. To bring them up to size to be tapped. Not bad for an old farmer, handy dancer, Jippo logger.